Hello and welcome to another episode of Air and Space Live Chat. I'm Beth Wilson. I'm an educator at the National Air and Space Museum, and today we are joined by Dr. Tom Waters, who is with the Center for Earth and Planetary Studies at the museum, and Dr. Jennifer Levasseur, who is a curator in our Space History Division. First of all, thank you both for joining us today.
Thanks for having us.
We are going to talk today about lunar photography from the Apollo missions all the way up to the LRO missions that are going on today. And I just want to pose this question, and we'll start with Jennifer to get started. Why did they photograph the Apollo missions?
Well, there's certainly plenty of reasons for that. And one of them, obviously, is we didn't get to go along with those astronauts. And so from start to finish, we needed back here on Earth to see what was happening up there, not just to believe it, but to understand it. And so we were the biggest audience, the public. Everybody around the world who didn't get to participate was also, got to be part of it through those photographs. And also, there's a huge contingency inside NASA who really needed those photographs to carry out their mission. So you've got scientists and engineers who are relying on those photographs to do their work. And so somebody like Tom would be one of those people even today who could tap into those images from the Apollo days and use them for scientific research. The engineers needed the photos to be able to understand things. A great example is the Apollo 13 mission. The astronauts photographed their service module as it was dropped away, and it was jettisoned before their re-entry. And that was the one time they got to see all the damage done to the vehicle. So those are really crucial to planning missions, to engineering needs, and really to make everybody, sort of understand what had happened.
And Tom, can you tell us a little bit about the Lunar Reconnaissance Orbiter now and why that's important to be photographing the moon?
Yeah, the LRO mission, it turns out, has been really revolutionary in terms of our ability to actually image the moon. And you'll see in one of those photographs that go by that you'll see this thing that one of the cameras looks like a telescope. Essentially, it is. It's a telescopic camera. In fact, we have two of them, and those are designed to take really the highest resolution images of the moon that until probably recently, although we're still not sure about the Indian mission, that we still have obtained resolutions that are better than 1 meter per pixel on the ground, which means you're actually resolving things that are on the scale of, let's say, your average coffee table if it's on the surface. And that's been, again, enormously beneficial to our understanding. And it builds directly on all the Apollo imaging and all the imaging that preceded it and then has come since then.
I want to remind everybody that we will be taking your questions. Put your questions in the comment section. We'll get to as many of them as we can. And if you let us know where you're watching from, we'll give you a shout out. We already have people in Morrisville, Vermont are watching, and Chambersburg, Pennsylvania. So thanks for watching and submit those questions. Ryan would like to know if you can see LRO with binoculars.
That's a good question, and probably not. Yeah, it would be pretty tough. In fact, I'm not sure that even the best telescopes that may have tried to do that would be successful in being able to see the spacecraft, because it's in a fairly low orbit. I mean, we only get maybe as far as about 100 kilometers altitude from the moon, and then we get down to 50 kilometers. So it's really hard to not have the moon just dominate the field, unless you're trying to see it on the during the phase of the moon when it isn't illuminated. The Earth facing side, the near side, isn't illuminated. So I would say probably no.
Jennifer, can you tell us what kind of cameras they were using on the moon? Was it anything special built to go on the Apollo missions?
So there were special built cameras. The astronauts themselves, in terms of what they used in their hands while they were in their spacesuits or while they were inside their spacecraft, were generally designed from something you could buy commercially, which is a Hasselblad. Hasselblads had been used for quite a while in the space program by the time of Apollo, and the company was really, modifying the cameras so that they would work in space. There were lots of features that needed to be changed. They needed to be made very lightweight, and especially on the surface of the moon, they needed to reflect some of that heat that would be coming from all the sun that was reaching them without the atmosphere to protect them. So the cameras could get really hot. So they used silver paint on them or silver aluminum. So it would really make them a lot easier to use. Now, inside the spacecraft, especially on the later Apollo missions, and this relates a lot more to what Tom does, is on the last 3 Apollo missions, there was a very large camera system put into the service module of the spacecraft. And the command module pilots on those 3 missions would have to activate those systems. And basically some doors would open, and this system of a panoramic camera, an altimeter, and mapping camera would work together to create very high resolution images of the surface of the moon. And astronauts had been doing that with Hasselblads up to that point, but this was really a very specialized camera for mapping and specifically. And the kind of cool thing about it is you have to remember these are not digital images. These are on actual film. And so on those 3 Apollo missions, astronauts actually had to go outside their command module and retrieve that canister of film to bring back to Earth. So those were often referred to as these really high, I don't want to say high danger, but they were really unusual EVAs, and only 3 people ever got to do that.
We have another question. Claire would like to know, how can you figure out the depth of lunar features by looking at 2D pictures?
Oh, okay, that's a great question. The depth can be done a couple of different ways using the images. One easy, simple way that was done before we had laser altimeters and other means to get to elevation was just looking at shadows. Just knowing how long the shadow, being able to measure the length of the shadow and knowing where the sun was when it was illuminating that part of the surface, you could figure out the depth of a crater or a trough, whatever it might be.
Dylan, who is 6, from Decatur, Illinois, wants to know how far away the moon is from Earth.
That's easy. It's about 283,000 miles away. So that's no small distance, but in terms of astronomical distances, it's actually pretty small, which is great because that's the reason why we can get to the moon in pretty much 4 days from the Earth, as opposed to other spacecraft launched to different bodies. For example, the Bepi-Colombo spacecraft just encountered the moon on its way to Mercury, and it's going to take years for Bepi-Colombo to finally reach Mercury.
We have a lot of people watching from all over New Hampshire, Alton, Illinois, Chicago, Charlestown, West Virginia, Charlestown, Indiana, Evansville, Columbia, Maryland, McAllen, Texas, San Diego, and right here in Arlington too. So not too far from where I'm sitting today. Well, let's see. Someone would like to know if LRO is still orbiting the moon, or is it done?
Oh no, absolutely. We are orbiting the moon right now, taking images. Pretty much, every day we're getting large amounts of the data, image data from the LRO. LRO spacecraft. And the really good news is the spacecraft is pretty healthy, and the orbit that we're in right now doesn't require a lot of energy to maintain. So we could stay in that orbit for another 6+ years, and if the spacecraft stays healthy, we'll be doing science operations and collecting data all through that period.
And someone would like to know, Jennifer, how fast did the Apollo spaceships go to get to the moon?
Well, just to get away from the orbit of Earth's orbit, now when they're in, when spacecraft is in Earth orbit, they're going over 17,000 miles an hour. There's an escape velocity that they need to reach to be able to get away from Earth's orbit, and that's someone could probably correct me out there, but I know it was over 25,000 miles an hour. So they have to achieve that velocity. They had or basically how it worked is the vehicle launched on the Saturn V to reach orbit, and then another engine on another stage of the Saturn V would have gotten them out of Earth's or at least pushing them away from Earth's gravity, and gradually they were escaping Earth's gravity and reached, once they got closer to the moon, then the moon's gravity was beginning to pull them in. So, and they had to do a similar maneuver on the way back to be able to get away from the moon's gravity. So maybe not quite, the pull's not quite as much. I'm sure Tom could comment a little bit more on the gravitational effects of the moon, but and the relationship between the Earth and the moon in that respect. But they had to achieve some pretty high speed to be able to just escape Earth's orbit.
Tom, how many lunar satellites are currently in orbit, and what makes LRO different from those?
That's a really good question. I think right now, let's see, there's probably at least, I think we have 3. We have an Indian satellite that is now imaging the moon. The Chinese have a satellite which is in position to at least do communications when they had an operational lander on the moon very recently, the operational rover lander. And then there's LRO. I think those are the only 3 currently in orbit right now. And the LRO, I think, remains special even among those, in that, again, we are in a very stable orbit, and we are attempting to image the entire surface of the moon at about 1 to 2 meters per pixel. In other words, we'll have that very, very high spatial resolution, those footprints on the ground. Again, we'll be able to hopefully see every part of the surface of the moon at a very, very high level of detail.
We have a question from Jada, who is 10, and she would like to know, and this is an interesting question, how many craters are on the moon?
Oh, wow. How many sand grains are on the average beach? It is a very large number, and this is one of the things when you look at some of the images that are probably going by that you're seeing now. You can see craters going down to the scale even that LRO and the LROC cameras are able to resolve. I mean, down to meter scale diameter impact craters. And so there are millions and probably billions of craters easily of all sizes, going again from the very small to extremely large impact basins.
Jennifer, Medellin says hola and would like to know, do you have any recommendations for beginning star or moon photography?
I wish I did. That's not something that I've ever actually gotten into. I recently saw an attachment that you can get for your phone that allows you to take long distance photography. And I do have some friends who do celestial photography and you know, do those kinds of things where you get an attachment for your telescope where you can take photos like that. I think there's a lot of great materials. I know just to promote the museum itself, we have an incredible staff who do that kind of work, and an education staff who give access to people, for looking through telescopes and are looking at things all the time. I know it's one of the most impactful things is to be able to see something through a telescope. I know I will not forget ever having seen something very far away through a telescope. I got to look at Saturn through the telescope that's up at the up here in Washington, D.C. And it is unbelievable when you can see it with your own eye. It's that thing, I've seen it in pictures, I can see it through images online from the Hubble telescope, but to really see it with your eye through a telescope is really special. So I can totally understand why people spend time really investing effort and money into looking into these things. So the things you need certainly are a very powerful telescope. Depending on what you want to see, you want to find something that's going to be able to reach whatever it is that you're interested in, and then finding one that you can adapt a camera to. A lot of cell phones are really good at this. I know that people find these great little devices and can attach them, and you can do some pretty amazing things even with just smartphone cameras these days. You don't have to have a digital SLR or something like that, but there are very economical ways to make that happen.
I also, you brought this up, our astronomy education staff often recommends that you find telescope club in your area. That there are a lot of people that hold star parties and go out with these telescopes, and that way you can kind of figure out what's right for you by trying these other options for people who do star parties.
It's helpful to remember too that the quality of your viewing is going to depend on where you live or where you set up your telescope, which is the reason that some of the local star parties here go out into the sort of western parts of Virginia, sort of out towards Winchester and Front Royal, which is directly west of here because there's less light pollution. I've tried a very simple telescope in my backyard to view the moon, and not knowing a lot about telescope operations, I'm not very good at it. I'm not good at lining things up. And of course, you have to remember too, everything's still moving. And so that does affect your viewing. You can watch the moon kind of traverse the sky over the course of, some hours. You'll notice its position change, but it's a little more noticeable once you look through a telescope. And so it can be really challenging. So it's a great tip to look for an astronomy club that can kind of give you some tips.
Tom, somebody would like to know if they can find the images, where they can find the images from LRO. Are they available online? Are they hidden somewhere?
They are not hidden. They are very easily accessible on a website. If you just Google LROC, LROC, ASU for Arizona State University, the site will come up and you'll find hundreds, we're probably up to thousands of images. I mean, if you wanted to see all the images or get access to every image that we've taken, and that now numbers millions of images since we have been in orbit since 2009, again, continually collecting data. Those are available on the Planetary Data Systems Network, which is a little more complicated, but those images are available.
And it looks like also that some of our fast-acting staff that's monitoring the feed has posted the LRO website in the comments, so you can actually look at the comments for that.
And just to connect with and give a shout out to Arizona State University, if people are interested in looking at Apollo images, there was a project a few years back that went through and scanned all of the original flight films, which are usually held in cold storage. And that's really important because you're going to the actual film magazine, the actual film itself. They went through and scanned those. You can actually get those as raw data files on a website called March to the moon. If you look it up, I think the website is tothemoon.asu.something. But look up March to the Moon, and from there you can go through each and every mission. You can pull images from all of that, and you've got about 18,000 Apollo images that you can look through, and a few more thousand from even the Mercury and Gemini programs if you're interested in the more Earth-facing material. So, but those are a great contrast, not really contrast, complement is the better word, to those that Tom's talking about with LROC. So you can see how far we've come in terms of imaging. Even though the those Apollo images, there's still something to be said for taking things with optical devices like those and putting them on film. It's really stunning when you see them at high resolution, just all the things that really could be seen. And especially since they were physically on the ground, it really gives you a different sense of the perspective.
Well, Anya, who is age 10, and Brady, who is age 8, want to know why astronauts can't just wear a helmet and need an entire suit.
Well, that's an excellent question. Astronauts, I like to call the spacesuit your personal spacecraft. So once you leave Earth's atmosphere, once you're outside, even at high altitudes, you need a what's called a pressure suit. Because we live at 1G, we are at a certain pressure here on Earth, and you need to your body needs that around it. So you have to basically carry that atmosphere with you. You have to carry that pressure and that content, that air. There's things that don't exist outside our atmosphere that you need to have with you, and so usually a spacecraft would do that for you. If you lived on the International Space Station, you'd live inside a machine that basically maintains that for you. But when you go outside the spacecraft, you can't live with just a helmet on. You have to carry that spacecraft with you. So a spacesuit is kind of like a mini spacecraft in that it contains all of your communication, all of your water, because you need to have water to live. You need to have that throughout the day, but you also need it to circulate close to your body so that you stay cool. It's very, very hot out there and in the sunshine. And then when you're in the shade, it becomes very, very cold. So you need to stay warm. So the layers of that suit function as a sort of miniature spacesuit or a spacecraft where they keep you warm, they protect you from things that could hurt you, and they maintain that pressure, which is critical because you're in a vacuum out in space. So you really have to have all of these things kind of combined together. And it's spacesuits are one of my favorite things to talk about and our favorite things to talk about at the museum because we have such an incredible collection of them. And it's really it's a labor of love to take care of them today, but there's good reason to do that because they are really unique inventions.
John would like to know, is the information gained by satellites shared with all nations, or are the satellites independently owned by individual nations and they retain their own info?
No, well, I guess the simple answer is that NASA, the European Space Agency, all the various space agencies do cooperate with each other, and it's very important, especially for any NASA mission, even if it's completely built and all the instruments were developed by U.S. Scientists, that all that data is shared. And in fact, the LRO, because we are taking images, very high resolution images of much of the moon, we are always cooperating with other space agencies, international space agencies, to help them in their efforts to land mission or put landers on the moon or whatever their operations are. So yes, there's a great deal of cooperation, and that's one of the strengths of exploring the moon right now, is it really is truly an international effort.
How does identifying features on the moon help us learn about Earth?
That's a really good question. Understanding, anything other than any other object in the solar system, especially we'll stick to the rocky bodies, because there are, most of the other celestial bodies outside of the gas giants are rocky bodies. by understanding those, it works kind of both ways. By looking at features on the Earth, it gives us an idea of what we're looking at when we see surfaces on other planets that have never been imaged before. And it works both ways, because sometimes we'll see on the moon, for example, features that aren't common on the Earth because they have been eroded away, because the Earth is a very highly erosive environment. It has an atmosphere, rainfall, features, especially small features, don't stay around for very long on the Earth. On the moon, even though the moon is an airless body, it's still erosive, but things don't erode at the rate on the moon that they do on the Earth. So there's a great deal to learn, because you're just adding to the number of examples that you get to see of a certain type of a process. So it really does help. Every planet that we explore, the moon and other planets, helps us in some way understand and get a better understanding of the Earth.
Jennifer, there's a question about Earthrise. Someone would like to know, are there plans to have more Earthrise photos? And why don't you start by explaining what the Earthrise photo is and its orientation?
Yes, one of my favorite subjects, as many of my colleagues know. So Earthrise is essentially what, if you're standing on our Earth and you're looking at sunrise, it's the same concept. It's that round thing coming up from behind the horizon. And so when the actually going back even earlier than astronauts visiting the moon, on Lunar Orbiter 1 traveled to the moon and took a photograph facing back towards the Earth. And so it captured exactly that perspective, which is in the foreground is the moon, and in the background, coming out from behind the surface of the moon, is the Earth. And so just like you get a sunrise, you'd have Earthrise. And so when astronauts were preparing to go to the moon on Apollo 8, part of, and I know a lot of people, this is often discussed in certain ways, and the language that's used is, scientists, astronauts, everybody at NASA knew that that moment would also come on Apollo 8, that the astronauts would be traveling around the moon, be able to look towards the Earth, in the direction of the Earth, and see that happen. And so when the Apollo 8 astronauts were going around the moon, they eventually turned their spacecraft around to be able to do that, to travel in the direction that pointed their windows in that orientation that would permit that view. And if you listen to the mission audio at any point, you'll understand that as that scene came into view, it's not that they didn't know that they were eventually going to see it, but you can imagine, as the first 3 humans to ever see that view with their own eyes, it'd be pretty darn surprising. And so you can hear it in the astronauts' voices. It's really exciting to hear and to listen to it. And so they scrambled for cameras, they grabbed some film. Frank Borman, the mission commander, was actually the first one to take a photo of the scene, and he happened to have black and white film. So if you look at it, it looks a little bit like Lunar Orbiter, though when you compare the two, Lunar Orbiter was sending back a signal, so the quality of the image is not as great as it was when the film was developed. The astronauts, of course, were, like I said, scrambling for film. Bill Anders then turned his camera up through the window and pointed it at that view with color film ready, and took what we consider to be sort of the most famous Earthrise image. And so the point of view that I tend to take on this is that most of the time when you look at an image like that, you understand it from the point of view of feet on the ground. And so most of the time when we see it printed in landscape view, which is that horizontal horizon, because that's what we know here on Earth. It's familiar and comfortable to us. But actually, when Bill Anders had that camera, that's not how he was in the spacecraft. You have to remember there's no up and down in space. So the surface of the moon could be on the right, on the left, at the top, at the bottom, and could be anywhere. And so when he was looking out the window, the moon was to the side. So if you look in the actual rolls of film, and you can do this on the Lunar and Planetary Institute's website, they actually have these in a nice strip format where you can look at each individual frame. You can see that the image is oriented in a portrait view. What's really ironic is that usually you see the moon on the right in those images, What's interesting is that when I spoke to Bill Anders about it, he said he was actually flipped upside down from that, so the moon was actually on his left. But his intention was to show it in the orientation that made sense to him in the moment, which was the moon on the right and the Earth coming from around the moon. They were traveling, and I like to explain it this way, they were traveling around the middle of the moon. They weren't traveling around the polar regions, they were traveling around the equatorial region. So it does make sense when you think about it, but just remember, there's no right or wrong. So however you want to put it out there, that's how it is, and that's fine. Will there be more Earthrises? I certainly hope so. There's probably an Earthrise image from almost every single one of the Apollo missions. So they did repeat that view multiple times in their photography. And certainly it could be replicated with any spacecraft that's traveling far enough away from the moon to be able to get that perspective. Just like we have another image that is the whole Earth in a single frame, that can be achieved from certain distances from the Earth today, but it's not achieved on film. And that's really where this difference is it's not with human eyes, it's with robotic eyes, I like to say. So there's a lot more to the story when you talk about it as something that people did. It's really fun.
Tom, we have a couple of questions. One is from Luca, who's age 7. The other one is from Avery, who is age 8 in Elkridge. Luca would like to know why the moon is white, and Avery wants to know if there are any pictures from the dark side of the moon.
Okay, well, let's take the first one first there. Why is the moon sort of white? Well, actually, it's not totally white, but it's because the white part that you see on the moon is coming from a certain type of rock that is very light colored. If you saw it, if you had it in your hand, it would be very light in color. And that type of rock makes up a lot of the crust of the moon. But if you also look at the moon, the side that we see, the near side, there's also these dark areas. Well, those dark areas are another kind of a rock that are very dark. And they're volcanic. In fact, if you've ever been to some place like Hawaii or somewhere where you see volcanic rock, it's pretty much the same type of rock. So you have this contrast between very light crustal materials and these very dark lava flows that give you that kind of contrast that you see when you look at the near side of the moon. The far side, yes, we never observed the far side from the Earth because the moon's near side is always facing us. It's called tidal locking. It just means that that body, the moon, as it moves around, is always facing the Earth. The same hemisphere is always facing the Earth. So we didn't see the far side until we actually had robotic spacecraft. And that was the first time we viewed it. And now we have all sorts of images. Again, if you look at the LRO, the LROC website, you'll see thousands and thousands and thousands of images of the far side of the moon.
Jennifer, Kirk, who's 8, is in Cub Scouts and learned that some astronauts were in Cub Scouts too. Can you tell us if you know of any astronauts that were in the Scouts?
Absolutely. In my position at the museum, I'm often the person that gets to greet and introduce astronauts when they come and speak to our audiences live in the museum. And that's something that comes up all the time with some of the male astronauts who come through. And so, yes, that's often, if that is true, if they were, and there are many who were Eagle Scouts, we often talk about that because there are so many scouting groups that then sort of, identify those people. And off the top of my head, I can't think of a single one, and I apologize for that. I want to say Tom Jones, and if Tom Jones is watching, I apologize if we're not an Eagle Scout, but Tom Jones is a shuttle astronaut who we know very well, and I seem to remember having that conversation with him in the past. And so, but it is something that it's really cool, and I would imagine that it's really easy to look up. I know I've looked up things, and this is something I would recommend. If you're curious about astronauts, look up ones You can just Google these things, astronauts from or astronauts who did this. I love to know who the astronauts are that lived near where I grew up. I grew up in Michigan. I just like to know who are the ones that are from Michigan. So, and those are, and that's always an interesting connection to have, or who went to such and such university, or who grew up local to the museum, because in our area, in the Washington, D.C. area, we obviously have lots of different universities and high schools that are technical places, technical schools, and so we end up with, quite a few astronauts, people who become astronauts someday. And it's nice to know, just sort of who you can identify with. It makes it a little bit easier, especially at a young person's age, to identify with those people. So I definitely encourage you to look up, if you're ever curious, astronauts who, grew up in your state or in your hometown sometimes, or near your hometown.
I've just been notified that Hoot Gibson was actually an Eagle Scout. He was a shuttle astronaut. Toby, age 11, wants to know if there are any pictures of a blue moon from the moon.
I'm sorry, any pictures of
a blue moon.
A blue moon. Of a blue moon from the moon. Yeah, I think we just went through this with the pink moon that just occurred, and these expressions are not really because the color of the moon is changing at any point. It's only because of the sort of attachment we put on what's happening during that particular season, so yeah, I mean, the one thing about the moon that does change is the size. Sometimes the moon, for example, this last full moon was what we call a supermoon, because it was occurring, the full moon was occurring at a point when the moon is closest to the Earth, so it actually appears larger because the moon is in this elliptical or shaped orbit that takes it further away at times and closer at other times. So that's something you can really look for. You can look for how the moon's size changes during different parts of the season and different times during the astronomical cycle.
This is an interesting question, again, for you, Tom. And I want to reference a conversation we had on one of the STEM in 30s. Somebody wants to know, does the moon have active volcanoes? And I remember you talking about if you were a dinosaur and you looked up at the moon, it would have been completely different view.
No, that's a great question. And one of the images that's probably scrolling by is this blobbish looking thing in a depression that was taken by the Lunar Reconnaissance Orbiter camera. That's actually one of these very young lava flows that we found on the moon. It's probably no more than about 100 million years old. So in geologic terms, that's very recent. And you're right, if you were on the Earth, and there weren't humans at the 100 million years ago, but there were some living things, including dinosaurs, that might have looked up at the moon and seen glowing red areas that were representing these very hot, fresh lava flows that were coming out. So to answer your question about are there active volcanoes on the moon now, we don't think so. We don't have any evidence of activity, at least the kind of volcanism that produces eruptions onto the surface. That doesn't mean, though, that there may not be things going on deeper down that just aren't making it to the surface. The moon is still a very active place geologically, so it's not impossible at all that there is still magma moving within the crustal zone of the moon.
Jennifer, Brandon is age 9 and from Frankfort, Illinois, and wants to know, is there another trip planned to go to the moon?
There are certainly hopes of going to the moon in the near term. If you pay attention to the news, you hear about it almost all the time now. NASA is working on a set of missions called Artemis, And the Artemis missions will use the Orion spacecraft, which looks an awful lot like an Apollo spacecraft, but it carries more people, and those will be launched in the near future. So hopefully in the next 1 to 3 years, we'll start seeing moon missions happening again. The goal is by 2024 to have a human step back on the surface of the moon. And so the Artemis missions will have astronauts fly to the moon's orbit, do that once, and then we'll have missions where there's actually a lander involved. Just like if you look back at the Apollo missions, you know that it was a 2-part process. You had to get to the moon, and then you had to go down in a separate spacecraft to the surface. They'll do a similar process again and land, and then come back. And the ultimate goal is to keep doing that for a long time. And so they want to put a vehicle in Earth or in lunar orbit that then astronauts could visit, could stay at, and then return to after their missions down to the surface. And that's called the Lunar Gateway. And so in the next, probably 10 to 15 years, we'll start seeing more of that kind of activity. And it's expected that the Lunar Gateway, as it sounds, is not just a gateway to the moon, but a gateway to Mars. And so that would be sort of a way station, if you want to call it that. Kind of like you think about a gas station or a rest stop on the highway. It would be a sort of stopping point for the journey onto Mars, because it's a heck of a lot farther. Tom mentioned earlier, it's about 280,000 miles to the moon. It's a lot farther out to Mars. And so we need a kind of a pit stop on the way.
I just got word, Jennifer, that people from Michigan are really excited that you are from Michigan.
Well, I was born and raised in Monroe County down near Toledo, so hello to all of you watching in Michigan.
We've got people watching in Williamsport, Pennsylvania, Oregon, St. Louis, Fairbanks, Alaska, Spartanburg, South Carolina, Grand Valley, Missouri, Massachusetts, Ontario, Texas, Ontario, Canada, Tucson. We got people watching in Michigan, Tampa, Florida. So we've got we've had a really good audience from all over, and we're running out of time. And there was one question that I wanted to wrap up with about the Artemis program, and this is probably more for you, Tom. The Artemis program aims to build a lunar base on the south pole of the moon in a crater. Why a crater?
Okay. Well, this is one of the key elements to a sustained long-term visit to the moon, which is certainly, hopefully, the intention this time, that we're going to go back to the moon, but we're going to stay there. Well, if we're going to stay there, we kind of need resources, and the most critical resource is water. And so why would that be? Why would you go to the South Pole for water? Well, at the South Pole of the moon, there are, and the North Pole for that matter, there are craters that never see sunlight. The sun never gets high enough above the sky to cast light into them. So they're very cold. They're the coldest areas on the moon, these permanently shadowed craters. And the idea is, and there's evidence to support, that some amount of water ice has collected within these permanently shadowed craters. And there is a debate about how much ice there is and how accessible that ice is going to be. And that's one of the reasons that we're going to be sending robotic missions to the South Pole to kind of explore that. But if there are large amounts of water ice there, it will be very important again, because water ice, you need the water, of course, to sustain human life, but water is also a main, because it contains hydrogen, can be broken down into fuel for spacecraft. So it will be very important and to have a resource of water, and that's why we're looking at going to the South Pole of the moon first.
Well, we have actually gone overtime again, which is great. We still we didn't get to all the questions, but we got to a lot of them. I wanted to remind everybody that we are doing these chats every Thursday at 1 o'clock Eastern Time. Next week, we will be talking about Apollo 13. It is near the anniversary, and I was told that Jim Lovell was also an Eagle Scout. So that's
And so was Neil Armstrong. I looked it up secretly over here, and I was correct. Tom Jones, shuttle astronaut, also an Eagle Scout. So I feel like I got one right today.
Thank you both for joining us. Really appreciate it. This was great information. Thank you all for watching, and we hope that you all are well, and we'll tune in next week. Thanks.